Okay, in this experiment we will be loading this beam and comparing the bending moment at the cut from the experiment to the theory. So this is the beam. Okay, these are the reaction supports. So this is RA, this is RB. Okay, so the beam is held up via these supports. You've got the cut located at a distance of 300 millimeters away from support RA. Okay, and the distance between the two supports RA and RB is 400 millimeters. So this is the table that is on the lab sheet, and I'll be filling this table out. So I'll be applying 100 grams, which is a force of 0.98 newtons. At the cut, I'll be reading the force from the transducer. Okay, I'll then compute the bending moment. Okay, and then I'll compare this to the theoretical bending moment. I'll then load the beam with 200 grams and again pick up a force from the rig, compute an experimental bending moment, and then see how that compares to the theoretical bending moment. So I have applied 100 grams at the cut. The force transducer, which is located 140 mil from the cut, located 125 millimeters. The force transducer is located 125 millimeters away from the cut. So to compute the bending moment, I will compare the force at this point, which I read off the rig as 0.7 newtons. I'll multiply 0.7 by 0.125 to get the experimental bending moment. So for 100 grams, the beam's been loaded with 100 grams at the cut. The force that the rig picks up is 0.7 newtons, and the experimental bending moment is then 0.7 times 0.125. Okay, if you refer back to your lab sheet, you can see that equation there. Bending moment at the cut is displayed force times 0.125. 0.125, remember, is this distance. So the force transducer, or the force at this point, is 0.7. Bending moment at the cut then is 0.7 times that distance. Now I will apply 200 grams at the cut and pick up the force in the rig, which is 1.5 newtons. Okay, for 200 grams then, that's a force of 1.5 from the rig. The bending moment of the cut is 1.5 times 0.125, which is 0.875. Okay, so now I've applied 300 grams at the cut. Okay, the force in the rig is 2.1 newtons. I will now determine the experimental bending moment. So for 300 grams, the rig picks up 2.1 newtons. The experimental bending moment is then 0.2625. Now I've applied 400 grams at the cut. The force in the rig is 2.9 newtons. I'll now determine experimental bending moment once again. Okay, that should actually be 2.8 newtons. Okay, so for 2.8 newtons, the bending moment at the cut is 0.35 newton meters. I'll now apply 500 grams. I've applied 500 grams at the cut, and the force in the beam recorded at the transducer is 3.5 newtons. So now I'll determine the bending moment at the cut. For 500 grams, the force was 3.5 and the bending moment of the cut is 0.4375. Now I will determine the theoretical bending moment. For the theoretical bending moment, I will use this equation. So W multiplied by the distance from RA to the support multiplied by L minus A, which is that distance there, over L.